All right, this video is going to cover Math Models Unit 10, Lesson 5, and probably Lesson 6. This is a lot of vocabulary heavy material. So, symmetry is the topic for Lesson 5. And symmetry is really just a way of saying things kind of have the ability to be reflected in themselves or rotated in themselves to be kind of made the same. So they give example here of like letters. Like A is symmetrical in the sense that if you fold it along this middle line, it would meet up with itself. And so what you're going to be doing is you're going to be looking at, I mean, they're basically going to be asking questions about whether things are symmetrical. And so we have two main types of symmetry that we're looking at. We have reflection or rotation. And so reflection symmetry is what you see here, where something is a reflection of each side. Whereas you have rotational symmetry would be something, see down here, where this matches up eventually. If you were to rotate that figure and turn it, it would meet up with itself. So I'm just going to ask some questions about that, some vocab. It just asks, look at the alphabet, which letters have rotational symmetry? In other words, which of these can I rotate and it would eventually meet up with itself? For instance, I. Eventually, I, if I rotate it enough, will meet up with itself after I rotate it all the way around halfway. H is very similar. If I rotate H, eventually it becomes the same again. O should be pretty obvious. Q is an example of one where, that doesn't work because that Q is only a Q when that little mark is in that spot. It can't ever be that again because there's only one of them. X is clearly rotational. S, also rotational eventually. That S will be rotated to itself, as will Z. So you're just answering some basic questions about this. So again, like you need to answer, is this reflection symmetry, rotational symmetry, neither or both? And you need to look at the definitions and decide, does it meet the kind of definition of that type of symmetry? Same thing with number 4, number 5, number 6, 7. These are all the same idea. Do these meet the rules for symmetry? And so you're just going to answer them based on that. You really just have those two, reflection, rotation. And then it could be neither and it could be both. So like looking at number, what is this, number 10, for example, that's pretty clearly none because it isn't going to be reflective and it isn't going to be rotational. So jumping over to number 6, lesson 6, perspective. And this is dealing with the way that three-dimensional shapes are looked at in mathematics. And this is having some trouble loading. Here we go. Perspective is like saying, okay, how do I show that things that are closer in view are actually larger than things that are further away in view? Even though they might be the same size, my perspective shows that things that are closer are larger. So it deals with things like scale factor. And so what you're going to be doing with this is you're going to enlarge figures by basically multiplying the coordinates. So if this says enlarge the figure with a scale factor of 3, you're going to multiply the coordinates by 3. So this 1, 1 would become 3, 3. And 1, negative 1 would become 3, negative 3. And negative 1, negative 1 would become negative 3, negative 3. So really you're just multiplying the coordinates times this scale factor number. More of the same. Now this is reduced by 0.5, so that really what it means is you're going to multiply by half. So multiply each coordinate by half. You see you end up with some decimals sometimes. Multiply the coordinates by 0.5. Again, more of the same. Multiply the coordinates by 2.5. More of the same, number 5. I'm not going to do all of these because you're just going to be multiplying the coordinates. And then it asks, what is the scale factor? So we have, it says the points of the preimage are circles and the points of the image are squares. So in other words, The gray was where we started, and then we went to the black. So how did it change? It went from 3 to 1. And that's how you do that right there. Very similar here. How did it change? How did we get the multiply? How did we multiply to get that? How did we multiply to get from gray to black? More of the same. I'll let you finish those on your own. And then I'm going to tell you you can skip 10 through, or sorry, 11 through, or 10 through 14 can be skipped. I'm going to pause for a second so we can go to the next lesson. I'm going to deal with tessellations and other kind of geometric relationships that you see in art and architecture. There's some basic stuff about this, what a tessellation is, what the golden ratio is. You find that stuff up in the text. The length of a golden rectangle is 20 centimeters. Find the width. So just understand what they explain up here is that in order to find the width, you divide by the ratio. So the ratio is this 1.618. So you're going to be doing 20 times, or divided by 1. For the delay here. 20 divided by 1.618, which is this ratio here that is what we call the golden ratio. And the golden rectangle has a length that is 1.618 times the width. So we're going from the length of the width, we would divide. So then we would have about 12. So we can see what we got there. And so we'll choose that answer. And now if we get the width and we need to go to the length, we multiply times the ratio. So you multiply times 1.618. This one, they give you the length. You need to find the width and then multiply to find the area. Again, you need to do the width to find the length, just like it in the previous problems, and then use those together to find the perimeter. This is more of the same. The ratio is very close to the golden ratio. So every other one increases by that amount. So if there are 34 spirals going right, we're going to do 34 times 1.618. So there should be about 55 in the next one. More of the same here. So this is more of ratios. So this is a little bit different, but the idea here is that she's using a ratio of 9 to 4. So if 9 and 4 are the ratio between the length and the width, and the width is 17, then you need to solve for this x. You do so by cross multiplying. Again, remember this is the length, this is the width. So we're going to cross multiply, which means we're going to multiply 9 times 17 and divide by 4. Hopefully you remember how to do cross multiplying, but you multiply these numbers and then divide by this number right here. So we're going to do 9 times 17 divided by 4, 38.25. See if we got that there. I guess we'll choose the one that's closest, 38. More of the same on the rest of these problems. You're just using the same basic problem solving for those as well. I'll stop here.